What if the real secret to creativity isn't about having unlimited power, but about mastering some really strict, unforgiving limitations? Today, we're going to hack our way into the Commodore 64 and see how its pioneering artists and programmers took these crushing hardware problems and turned them into a totally iconic visual style that honestly still inspires people today.
So I want you to forget about terabytes and gigapixels for a minute. The year is 1982. You've just turned on your brand new machine, and this is what you see. That number on the screen, 38,911 bytes free. That's it. That is your entire creative universe. And this big blue screen, well, that's your canvas. And the rules for painting on it are, well, let's just say they're very specific.
Okay, so the very first thing you got to get your head around are the ground rules. See, the Commodore 64 didn't just give you one canvas to work with, it actually offered two. And choosing between them, that was the first and maybe the most critical decision any programmer had to make. And here it is, that big, fundamental trade-off. Over on the left, you've got Hires mode. That's a 320 by 200 grid of perfect, razor-sharp square pixels. The lines look super crisp, right? But your color palette is incredibly limited. Then, on the right, you've got multicolor mode. Now you get more colors to play with, which is great, but look close. The pixels are these wide, fat rectangles. Your horizontal resolution is literally cut in half. So, sharpness for color or color for sharpness? That was always the choice.
So once you've picked your canvas, you need your tools. The built-in Simon's Basic gave programmers just 3 really fundamental commands to build entire worlds, all out of simple geometric shapes.
First up is rec, which you guessed it is short for rectangle. And it is beautifully simple. You just feed it the X and Y coordinates for that top left corner, give it a width, give it a height, and boom, a perfect outline just appears. It's clean, simple, and super direct.
But what if you wanted to fill that shape in? Well, for that, you'd use block. But here's where things get kind of interesting. Instead of thinking in terms of width and height, block thinks in absolute coordinates. You give it the top left point and then the bottom right point, and it just fills everything in between. A slightly different way of thinking.
And for anything that wasn't, a box, you had circle. You define a center point, and then a horizontal radius and a vertical radius. And here's the really clever part. Because those two radii were totally independent, you could easily make perfect circles, or you could stretch them out into any kind of ellipse you wanted, just by changing one number. Pretty neat.
But this simple little toolkit wasn't nearly as straightforward as it looked. The hardware itself had its own really strange quirks, a bunch of hidden traps, and some totally non-negotiable rules that could turn a simple drawing command into a system-crashing catastrophe.
And this is where the real challenge started. What happens when your code doesn't line up perfectly with what the hardware is expecting? The answer? Well, it could be bad, really bad.
Let me introduce you to the bad mode. The rec command was basically mathematically blind. It had no clue where the screen actually ended. So if your starting x coordinate plus the width you gave it went even 1 pixel beyond 320, or the y plus the height went past 200, the entire computer would just lock up. Done. No warning, no error message, just a dead stop. Precision wasn't just a goal, it was a survival requirement. Then there was this totally mind-bending distortion. You could write code for a perfect 100 by 100 square. The math is perfect. But when you ran it in multicolor mode, this is what you got: a wide, squat rectangle. So why did this happen? Because the hardware itself physically warped the canvas. Those double-wide pixels meant that even though your math was totally correct, the visual reality was something else entirely. Programmers had to learn to actually code for this distortion.
But this was the biggest rule of all. The screen was secretly divided up into a grid of 8 by 8 pixel blocks. Think of it like that. And inside any one of those tiny little blocks, you are only allowed to have 2 colors in high-S mode. One color for the actual pixels you're drawing, and one color for the background. That's it. It was like a coloring book with a very, very strict rule on every single little square.
And what happened if you broke that rule? Well, if a shape dared to bring a third color into one of those blocks, the hardware didn't compromise. It would just violently overwrite one of the colors that was already there. This created that infamous color clash or visual spillage you see in so many old games. It's one of the most defining and honestly frustrating visual quirks of that whole era. So you're faced with system crashes, warped shapes, and ugly color clashes. What did programmers do? They didn't give up. They learned to hack the hardware, and they turned these limitations into their greatest creative assets.
So how do you beat that nasty color clash? Well, you embrace a different limitation. This is what's called the perfect overlap trick. Programmers figured out that while high-res mode only allowed 2 colors per block, multicolor mode actually allowed 4. So by switching over to multi and meticulously planning out their patterns, they could create these flawless, complex gradients that would have been totally impossible in high-res. They basically cheated the system by playing by its other, lesser-known rules.
Okay, here's another brilliant example of exploiting a weird quirk. The C64 has just 16 colors, right? Numbered 0 to 15. So, what do you think happens if you tell it to draw with color number 20, or 50, or even 100? You'd expect it to just crash, wouldn't you?
Nope, not on the C64. The system doesn't crash at all. This is the 4-bit color wrap. Turns out, the hardware was designed to only look at the first part of any color number it was given. It completely ignored the rest. This meant programmers could just keep adding to a number in their code, and the colors would automatically and smoothly wrap around the palette, just looping from 15 right back to 0. This made for these mesmerizing color cycling animations with incredibly simple code. It was a total happy accident.
All right, let's go back to that deadly screen edge for our final big secret. We know the rec command is super fragile. You touch the boundary and it freezes the whole system. But the circle command, it was built different. It was resilient.
If a circle or an ellipse went off-screen, the hardware would just stop drawing the arc and slice it off perfectly clean. This wasn't a bug. It was a predictable, reliable behavior. This graceful failure meant that programmers could intentionally draw shapes bigger than the screen just to create these perfect cutoffs and unique compositions, turning a potential error into a really powerful design feature.
So when you look back at all of these quirks and all these clever workarounds, a really clear picture starts to emerge. It wasn't about fighting the machine. It was about understanding it on the deepest possible level.
And this is really the core takeaway from all of this. The artists who created the most memorable, most amazing graphics on the Commodore 64, they weren't the ones with the best tools. They were the ones who best understood the rules, and, maybe more importantly, all the loopholes of their canvas.
I mean, think about it. Every single limitation became a source of creativity. That fear of a bad mode crash, it forced programmers to be surgically precise. That strange 2-to-1 pixel ratio, it made them completely rethink composition. The strict color limits, they led to all those clever tricks in multicolor mode. And all those random hardware quirks like the color wrap and the edge cutoff, they became powerful artistic tools in their own right.
And this kind of leaves us with one final thought. We live in an age now of seemingly endless computing power. But have the constraints really vanished, or have they just changed? What are the 8x8 color limits of today that are forcing a new generation of artists and designers to be just as ingenious? It's something to think about. Thanks for tuning in.